Our next speaker is Dr. Pankaj Dayama, Senior Technical Staff Member and Manager at IBM Research India. He leads research on AI for industrial system, particularly advanced time series modeling for manufacturing, operations, and IT system. Dr. Dayama works closely on translating research innovation into deployed industrial solutions. Please welcome Dr. Pankaj Dayama.
Hi, good afternoon everyone. I'm Pankaj from IBM Research. Today I'll be talking about some of the work that we are carrying out on building these foundation models for time series. So yesterday Amit Singhi did briefly cover time series and geospatial foundation models. So I'll try to cover the complementary piece in terms of focusing on models that are basically relevant for time series diagnostic tasks, and then also briefly talk about how these models are being infused into different products, right? So in general, time series, I guess it's code for enterprise operations. Vast amount of time series data gets collected. And the thing of interest is once you have this data, what type of insights can you get out of this data, right? So are there any trends, interesting trends? Are there unusual patterns in the data? If given a data, can you forecast what would happen in near future? And once you have these insights, maybe you can do some type of optimization, right, around this. Given that this is what you expect, can you control how the series will behave, right? And this essentially, all these things help in proactive decision making and also reducing your cost or improving your revenue, right? And when we talk about applications, few examples, like if you talk about IT infrastructure monitoring, you may be interested in predicting the storage, let's say, resource requirement. And if you have a good enough prediction model, then that would help you prevent any costly outages, right? Similarly, in supply chain forecasting, product demand would be very useful so that then you can position the inventory for different products and then basically reduce your inventory positioning or wastage cost and improve the revenue or profitability, right? Likewise, in manufacturing or quality control domain, you have a lot of data that you collect through sensors. And it's important to analyze these data so that you can optimally control how the process is evolving, right? Or if you can identify certain unusual or emerging issues in the operations of the equipment, right? So in various settings, I guess you have a lot of applications for this. So again, I've listed down applications in heavy metal industry, manufacturing sector, energy utility, maybe you want to forecast energy generation or energy demand, and information IT sector, again, I talked about these examples, right? So in general, when we talk about these different tasks, right, and we want to have a common model that can, like a foundation model that can help us uh, basically solve some of these downstream tasks. So the challenge is that some of these tasks are slightly different. So a good way to categorize this is like diagnostic type of tasks, like imputation. If there are certain missing values in your time series, how do you impute it, right? And we are not just talking about a univariate time series, it can also be multivariate, right? So you have cross series correlation, right? Then anomaly detection, similarity search. If you want to, given a time series, you may want to retrieve similar time series in the past, right? Segment in the past. Or classification, given a pattern that you're observing, can you predict that whether this would lead to a failure or not, right? So some classification type of task. So all these tasks are like bidirectional in the sense that you can look at the entire time series segment and then say what something about that series, right? Whether there are anomalous signals within that series. Whereas the other task is forecasting is slightly causal in nature, where there is a temporal aspect. Given that whatever you have observed till now, can you say what will happen in future, right? So, so that's where I guess I was listed them as two different categories. And what we have done is, yeah, for each of these categories, there are like different, instead of having a common foundation model that can generalize across all these tasks, consciously what we have done is we have built two different pre-trained foundation models. So one is Granite TTM, that is mostly for forecasting type of tasks. And we also have this IBM Granite TS Pulse, that's mostly for all the other diagnostic tasks, right? And the key thing about the architecture is we have tried to keep it small. So these are really small models in terms of number of parameters, like 1 to 5 million parameters. The results are very, very competitive, and all the inference, everything can be carried out on GPUs. And this can be tuned, like given like time series, it's very, very difficult to have a general representation that can work across different domains. So one of the key things for industrial use cases is that given the data that you get for a given domain, can you quickly fine tune these models and show that it works, right? So for real world industrial scenarios, where yesterday maybe Amit also talked about this control response scenario for manufacturing setting. So these are like very quickly you can fine tune these models and they perform pretty well, right? So with that, I'll focus on the first category, mostly the model for diagnostic type of tasks. So TS Pulse, yeah. So TS Pulse model in general, the key idea over here is it looks at dual spaces like time as well as frequency space, and does masking and tries to do dual space mask reconstruction. But not just that, many other efforts in the past have tried this, working on it. But the key thing over here is it looks at different levels, right? It's not just spectral versus temporal, also local versus semantic, right? So can you learn these embeddings in a such a way that they get disentangled, right? So that's where there are like multi-output heads, and this multi-output heads over here, like time, FFT, probabilistic head, and future head, they essentially help when you train the model and have different weightages for this, they essentially help focus on different parts of the embeddings. And that essentially enables us to disentangle these embeddings so that for different types of downstream tasks, you can focus on certain portion of the embeddings and show that it helps in certain tasks, right? So the key idea over here is dual embedding disentanglement. That's what is enabled in this architecture, right? And then, so there are key components for each of the tasks. So we have like hybrid masking. So the masking strategy that is used for some of these models, we have hybrid, like we do point masking of data, time series data, also block masking. And I'll briefly talk about how we do multi-output triangulation so that it helps in detecting different diverse type of anomalies, right? Because when we talk about foundation model, ideally it should work for different data sets that may have different types of anomalies. And also the semantic or high level embedding, how that can help in retrieval type of tasks. And then because we have this disentanglement, the TS lens component essentially during fine tuning, because classification, usually the models can be used in two ways. One is zero shot, like the pre-trained model can be used as is for your task, or you do fine tuning. But classification, the class labels, everything is very problem specific. So you need to do fine tuning of the model. And that's where this component can essentially focus on specific parts of the embeddings to help in the good classification, right? And in general, the model does pretty well on all these tasks. So let me get into details of some of these tasks. So let's look at the imputation tasks, right? So if you have data from equipments and so sensors and other things, a lot of time series data gets generated, and many a times because of various reasons, right? Sensor fault or communication failure, there are a lot of missing data, right? And this data can be either at a given point there is some noisy value, so that's missing, or maybe there is connection failure, so you have block level like contiguous values that go missing, right? So, and whenever you want to build any meaningful model, it's better to impute some of these values. And traditionally, there are a lot of statistical techniques in terms of maybe interpolation and forward fill. There are various techniques that people do for imputing some of these values before doing any meaningful downstream processing or predictive modeling for time series, right? But what we show using TS pulse and hybrid masking strategy, the results that we get both by using the model as zero-shot model, what a pre-trained model, zero-shot for imputation, as well as doing some amount of fine-tuning for the domain. The results in terms of metric where lower is better is the results are much better than both other foundation models as well as statistical and deep learning based approaches, right? So the other task is anomaly detection. As I briefly mentioned, anomaly events are of different types. So you may have some contextual anomaly or suddenly some flip or different patterns, right? Or suddenly it goes out of scale. So all these different types of anomalies can be encountered, and when you claim that you have some pre-trained foundation model that works, ideally you want them to work on all these, should be able to detect any of these types of anomalies, right? And so that's where in TS Pulse, because the way we have disentangled the embeddings, so now the key component over here is that we do this multi-head triangulation. So where you take the data from this time series reconstruction, the frequency reconstruction, and the forecast part. So all these data sets, the streams are taken and they are processed by this to come up with the anomaly score, right? So you try to look at this output, compare, and then see how do you come up with a robust anomaly score for this. So here because we have this clear separation, it essentially gives us boost in terms of performance, right? And again, in this case, both for univariate as well as multivariate data, we have compared this with other pre-trained models that are available like moment times FM Chronos, as well as statistical and other approaches. In general, this is the metric that has been proposed in literature, which is unbiased. So VUSPR, higher is better. So in general, TS Pulse zero shot as well as fine-tuned model does perform much better than some of the other approaches. And keep in mind that this is like very, very lightweight model. So all these things can be done on CPUs, right? So this is for univariate. Similarly, for multivariate data, where you also want to model the cross-channel correlation. So there also the model performance is pretty good. The other very common use case and high impact use case in industry is how do you compare and retrieve similar instances of time series, right? So many a times if you observe certain patterns, which is unusual, and that might lead to something, right? So you want to know in past whether similar patterns have been observed and whether that cause certain maintenance or certain failure, right? So that you can do some proactive measures, right? So here I think one of the key things is how do you retrieve similar patterns from the time series, right? So here again, the semantic embedding that TS Pulse has, this embedding essentially helps us give very good retrieval accuracy, right? Performance in terms of retrieval. So what we have shown is that given we index all the time series whatever is there, so using the TS Pulse embeddings, the data gets indexed, and then given a query, it's like RAG pattern, right? So now how do you do proper embedding or indexing of the time series? So there TS Pulse embedding is used for indexing, and then given a query, the model, you can essentially retrieve similar examples. And what we show is these embeddings, whatever we get from TS Pulse, are robust to shifts in time, magnitude, and noise. So they are pretty robust embeddings, and that essentially helps in this task, right? So here again, few examples of what's the query that is provided, what are the retrieved examples, and the similarity, right? So again, in terms of performance on various standard well-accepted metric for similarity search, the model does very well, right, in terms of retrieval. The last task is the classification task, where given a pattern of time series, you want to know whether this is for class A or class B, right? maybe it can be multi-class problem as well. And here, I guess the key thing is TS Pulse introduces a component called as TS Lens that essentially enables focusing on certain part of the embedding, so that helps in your classification. So, but this thing has to be done. There is no zero-shot performance. This is very problem specific. So you need to fine-tune the model so that you can get the representations well separated out for a given task, right? So in general, what we observed is for all these tasks, the model performance is much better than the state-of-the-art approaches. So one common pre-trained model with some task-specific specialization does reasonably well on, or it's very competitive on all these tasks because of all these differentiating components, right, that helps in achieving that performance or generalizing, right, across data sets. So with that, I'll just get into some of the infusion stories, right, where these models are being used in different products, right. So one of the things, one of the places where we have integrated this model and it's released as part of the product is this network intelligence product. So where essentially these AI models are pre-trained on network telemetry data. So this is multivariate data. So you have this data from various networking domains, right? RAN, IP core, SD-WAN, and different networking data. And you want to essentially use some of these models to, and this is like mostly streaming data, right? And you want to use these models to detect anomalies or forecast issues, right? Constantly occurring issues. And there the idea is that it takes a long time for traditional ML based approaches to have to get a model and work over here. And here we try to use TS Pulse model, and I'll briefly talk about the experience, right, with that. And once you have these issues in general, the product, you also have a reasoning LLM that can then look at the context and then generate some root cause hypothesis. Maybe this is triggered because of certain things, right? And then finally, you have agents to that does end-to-end automation, right, of detection, analysis, or what are the remediation workflows, right, for whatever issue has been raised, right. So our focus has been with this product on providing the first component on time series model. So I'll just talk about that. This is just an example, right? So in IP domain, one of the most challenging anomalies or failures is that traditional monitoring systems do not capture is this packet loss, right? Silent packet loss. And these is without generating any error, everything looks pretty normal, but packets get lost, right? And that essentially leads to degraded performance or complete communication failure. So how do you proactively essentially identify some of these things, right? And this is where I guess what we have done is this product has started leveraging our TS Pulse model, and we look at data sources from this domain. We do extended pre-training. Whatever open source model we have, we do extended pre-training of this model on this domain-specific data set because large amount of data is available. So we do extended pre-training, and then the TS Pulse model is essentially used as a core model for real-time anomaly detection, and then followed by the agentic workflow, right? But the key thing is the latency requirement, right? So the important challenge that we addressed over here is with a lot of innovation on top of the open source model is that the latency requirement in this case was milliseconds, right? Within milliseconds, you need to process the context and flag something as anomalous, right? So we could achieve almost 3 order of magnitude improvement over what our model we have open source through a lot of innovation on top of that, right? So again, here we have been working with the products for all those four. The first chart, the previous chart was just on anomaly detection, but they also have requirement for all the other different diagnostic time series tasks in terms of imputation, classification, and similarity search, right? So we have been working very closely. The first feature on anomaly detection is already released as part of the product. Some of the other things on this networking domain for these tasks is we are currently delivering those things to the product, right? So here, as I mentioned, so we have, today I'm just talking about TS Pulse model, but we also have this tiny time mixer model that the product is using for forecasting some of these network traffic and degradation, some of the other KPIs. But the key thing is for streaming data, we have essentially achieved low latency requirements of 1 to 3 milliseconds using some of the innovations that we have done on top of the model architecture. The other place where we have used this model is in IBM storage insights. So this is like essentially for flash storage systems. This is a AI ops platform that provides different types of insights on the flash storage system. So they monitor almost 20,000 devices, and they look at IO ops data. Almost 350 KPIs are getting monitored. And currently they use this AI, statistical and AI models, that is per device they use these models for performance forecasting, capacity forecasting, as well as deviation, right? So every device they have a separate model that is maintained. And what we have done working very closely with the product team is to leverage for different types of planning use cases in terms of if you want a new workload to be placed on your network of storage devices, can you essentially recommend what is a good system on which you should place this workload given the current observation of the performance KPIs? And also capacity planning. So these are planning use cases, and operations, day-to-day operations use cases in terms of generating alerts for any anomalies, right? So here we have used TTM for this planning use case and TS Pulse essentially for the anomaly detection use case. And in general, these models, and this is just one model across all the devices, right? So we have delivered one model that is used across 20,000 devices being deployed. And in general, what we have observed for as compared to some of the other techniques they have used, currently what they had initially was profit, but they also tried some of the other methods. But in general, TS Pulse, the TTM performance for this forecast is much better. And this, as I said, this was released as one of the features in earlier this year is on this workload placement advisory. So where essentially given the storage system KPIs that you are monitoring, essentially these forecasting models essentially are used to get the predictions of how the future utilization or KPIs would look like. And given a new workload, the placement advisory will utilize this forecast and run some optimization where new workload, different types of workload you want to analyze and come up with a recommendation that, okay, if this is the type of workload, let's say a new Oracle application you want to install on your enterprise thing. So maybe you should look at this flash storage device on which it should be done, right? The storage should be done, right? So this resource optimization essentially utilizes some of the forecast that is generated by the time series model. Similarly, for anomaly detection, we have been, like in the case of storage, the network intelligence. So here also the anomaly detection, the TS Pulse based anomaly detection does very well, and it does not require any training for any new device, right? So in a zero shot manner on CPUs, one pre-trained model performs pretty well for this use case. And we can also establish like what are anomalies get detected. There is a strong correlation that is established with whenever there is a tickets that get generated in the system, right? So the way we have validated is, okay, this model gives out certain anomalies, but later on within few hours, certain tickets get generated. So that way the correlation of this anomaly, and also we give strength of anomaly, right? So if there is anomalies in multiple KPIs, maybe it's a very strong signal saying that, okay, something undesirable may happen. So we do provide, the strength report for different types of anomalies. So all these things, what I have talked about, these models are open sourced, available on Hugging Face for anyone to try out for different use cases. And what we have provided is also cookbooks or recipes on for different examples in energy domain, in manufacturing domain, as well as IT domain. Few examples on how these models can be used, right? Both we have notebooks provided for zero-shot usage of the model, as well as if you want to do fine-tuning of the model, right? So everything is there out and open. I encourage folks who are interested and it's very relevant for your domain to try out these models and reach out to us, right, in case you need any help. Yeah, that's it I had.
We can have few questions. Some one generic question. I know that IBM has built many granite models, many variants, right? Is there any plan like GPT API, right, to productionize it? Because though it is on the research stage, right, I don't really see the popularity compared to the OpenAI, Anthropic, or even the Gemini. What's the plan, right? How are you going to make this more adapted and usable?
Yeah.
Because it is in the research mode. Those who are even, I'm not sure that many might not even aware that IBM is building the foundational models, especially the Granite, and full of models. It's not one, right? Multiple scientific applications. Is there any business plan towards that, or is it open for community research collaborations? Maybe in that direction, the community here will be interested to actively engage with IBM.
Yeah.
So in that direction, could you please throw some light?
Sure. Yeah. So currently, right, so some of the models, as I said, they are open source with all the recipes provided. But as a product also, we have integrated this into IBM platform, watsonx.ai. So these models, the TTM model for, not TS12, but TTM is available for both zero shot as well as fine tuning as part of watsonx.ai platform, right? So where many of the partners and clients are consuming it from the platform. So it's already there.
Okay.
It's already integrated into the platform.
Sure.
The TS Pulse model, we are still in the process of integrating it. But the TTM model for forecasting is already integrated into the product.
Great. And also the another good point about the IBM models, right? Not only the open weight models, and we also know about the data set. Everything they open it up. It's truly open source models, right? And if at all really someone wants to really try it out, and these are the models, and one should really take it up and then try, because you know what data set gone into the model, and if you like it, you take it. Otherwise, you can also
in fact, one of the professors in IISc, Professor Arjunan, he has used these models, and now we have a domain-specific, energy domain-specific TTM and TS Pulse model.
Correct, yeah.
So that is for energy domain smart meter data because everything is there out in open. They could pre-train the model on that domain, and that does very well on some of the domain data.
Yeah, thank you. Okay, so we now with this, right, we are going to go for a break, but before that, a small token of appreciation. Thank you, Pankaj.
Thank you
for your presentation and then for your time.